Alright, this is Unit 2 Exponential Functions, Day 4, Solving Exponentials. You'll need what's going to happen here on this problem for the rest of the day to make sense. What you need to do when you're solving these exponential equations is you'll actually need to get the base to be the same on both sides if possible. What's going to happen here is both bases can be a 3. So this one's already a 3. This one over here can become a 3 if I change it to 3 squared. Now it will still be to the 4th power because this will still be 9 to the 4th power as it was, but I'm changing the 9 to a 3 squared. Reason why I'm going to do that, 3 to the x equals, this will now be 3 to the 8th power. I just multiplied my exponents whenever I do a power to another power. And now I can say that since both bases are now 3, x must equal 8. I'm actually dropping my bases there. There is a step that's actually taking away, and we'll get to that later in this unit, but right now you need to understand how to get the bases to match in order for them to be canceled out. So here's our first actual example here, and we're going to see that I'm going to get these bases to be the same. Similar to the last problem, the 2 is already good, but the 4 could be changed to a 2 squared. Now I'm going to go ahead and write down the exponent that was on the 4, the 2x minus 1, and now I'm going to rewrite the 4 as a 2 squared. Alright, now I'm going to simplify that right hand side to where it's going to be 2 to the power of 4x minus 2. I just multiplied my exponents. Remember, you'd have to distribute right here with your exponents. Now I can drop the bases, so 5x does have to equal 4x minus 2. To solve this problem, I'll subtract the 4x from both sides. Get 1x equals negative 2. And that's it. There we go. And you do always want to plug these back into the original problem just to check your answer and make sure you're doing the right thing. Sometimes it's a little bit more difficult. This is kind of a weird little curveball that gets thrown at you. Some people try to reduce just the 8, but you can't reduce the 8 to a base of 4 because 8 is 4 to the, it's going to be an irrational number. You can't do that. What you have to do on this problem is both bases can be reduced to a base of 2. So that's what I'm going to do here, is I'm going to change the 4 to being a 2 squared, and it's still to the 3x. And I'm going to change the 8 to a base of 2. It's 2 to the 3rd power. You got to be used to thinking about higher powers than just the square that you've been using for so long. Alright, now that I've got that, I'm going to simplify both sides. So this will be 2 to the 6x when I multiply there. The right hand side will be 2 to the 3x minus 3. So now I can drop my bases. So 6x equals 3x minus 3. I'll minus the 3x from both sides. So 3x equals 3, divide by 3, and I get x equal to 1, and I'm done. Alright, this is by far the most difficult problem today. The word problem I showed you the previous day showed you where you were given the growth rate. Here, we're not given that growth rate. We have to calculate it first. Alright, I'm going to really quick reference that y equals a times b to the x power. Now, x, it says in the problem, needs to be the number of years since 2000. So if x equals 0, that's the year 2000 that you're talking about. What that tells me is I do actually know my initial population, my A value, needs to be this 1,321,045. I need to figure out the B though. That takes a little bit of math, and I'm going to do that over here. So if y equals a times b to the x, that's where I'm going to use the other point. It's actually giving me a coordinate of 2007, which would be an x value of 7, and 1,512,986. That's my y value. So I'm going to use that point in this form where I'm going to drop the y in, 1,512,986 equals, and I do know my A, it's coming from the year 2000, 1,321,045 times B to the x power. Now I actually know my x is from that coordinate 7, so B to the 7th power. That's actually going to set me up for figuring out what B is now. What I'm going to do is I'm going to divide both sides by the A value that I had, the 1,321,045. And I'm definitely using a calculator here. Alright, and what I get is now b to the 7th is equal to about 1.14, I'm going to say 529. I'm taking it pretty far out, so that way whenever I do an operation here in just a second, it won't distort that number too bad. Now I'm going to solve for b. Now how I do that is I use a reciprocal power. If it's to the 7th power, to cancel that out, I'll raise both sides by the 1/7 power. So b to the first now will equal, and I'll just hit raise to the 1/7 power in my calculator, and I get 1.0195. So I'm just going to say 1.02. Usually I'll just go to the nearest percent on these things. Depends obviously on what context of the situation. Now I've got my b. Now I'm going to make my function, and my function will be y equals 1,321,045, as you had seen with my a value right here, going right in. Now I know my b value is 1.02, and I can now raise that to the x power. I've now created my function. Again, you got to do a little bit of calculating to get what your b value will be. Now I could use that function to predict for the year 2010. Let's say I could plug a 10 in for x and effectively predict the population. Evidently, this population, by the way, is experiencing about a 2% growth per year in Phoenix. Now, this next problem might be a little bit difficult for you to understand by watching this video, so you might have to ask me questions in person as far as what the n means. This is still a times b to the x power. Just sometimes, like with accounts and everything, we compound the interest, meaning that that is when the interest itself starts building interest. It becomes part of your principal and itself builds interest. So the more often it compounds, the more interest will be built. Now if you're investing money, you want it to compound more often. If you're borrowing money, you want it to compound less often, is a basic principle. Okay, principal is always the value at the beginning of your time period. I just talked about n. Rate is your interest rate, and you'll always put that in decimal form. So like here it's 5.4%. You're going to use 0.054 when you plug it into the formula. T is your time in years. Sometimes that time period can be changed. It's pretty rare though for bank accounts. All right, let's go ahead and get going. The amount that we're going to have in this account is equal to $4,000 is placed into the account, so principal is $4,000. Dropping that in for principal. This is going to be 1 plus my rate, which it said was 5.4%. Again, I'm using 0.054 over my number of times compounding. Now, since it's happening quarterly, that's quarterly will happen 4 times in a year. So that's what my n is. Quarterly is 4 times. And that's it. Same n is going to happen right here in the exponent, according to my formula, times my number of years, which in this case is 8 years. The other likely combinations happen monthly. That'd be 12. Daily, 365.25, because 1 every leap year. And there's other ones. Just let me know and I'll make you a list if you need them. All right, now all I got to do is type that in my calculator. Hopefully you typed it into your calculator as well. You know you did it right if you got $6,143.56. Now how do you know what to round to? Well, in America, we go to the nearest penny, so the 100th place. All right, same kind of problem. I've already thrown the formula there. The amount in the account will be based off the principal, which in this case is $6,050, the amount at the beginning of the time period, times 1 plus my rate here is 4.6%. I'm going to use 0.046 divided by the number of times compounded. Since this is compounding daily, there are 365.25 days each year. Now, some people think that's only 365 days. Well, you've got to remember there's a leap year every 4 years. So, I'm going to include it by using a 0.25. Raised to the number of times compounded, 365.25, times the amount of time it's in the account, 6 years. If you miss that 0.25, it'll only usually make a difference of a little bit, but a little bit can mean you get the wrong answer on multiple choice. It just depends how mean they're going to be. I like going ahead and just being safe and including it. Now I'm going to type this in my calculator and invite you to do the same on yours. You'll know you did it correctly if you got $7,972.84. All right, that wraps up the lesson. Please let me know what questions you've got. Thank you.